Hi everyone, my name is Ravi and welcome to 19th class of P&C. Okay, in this class we'll discuss the applications of the concepts we discussed in the previous videos, right? See the question here, number of ways of distributing 19 identical balls into 3 identical boxes, right? Now how to solve this question in the best possible way, right? Without making cases, right? To solve this question in best possible way, what you can do is assume this. See, these there are 3 identical boxes, right? Assume these boxes to be different. Huh? Get this concept right. It is same answer is same as the unordered solution of this equation. A plus b plus c equal to 19 that we discussed in the previous video. But why? Just get this concept right. Assume this this as assume this as 3 different boxes. Now what will happen? What will happen if it assume this as 3 different boxes? See, now A, B, C are 3 different boxes. It is equal to 19. If we write total number of solutions as 21C2, 19 plus 2, 21C2, because all can be 0, right? Here, it is not necessary that each box contains a ball. No. So total is what? Total is 21C2. Now, 21C2 is what? It is ordered solution. Obviously, that means if I can make cases here, if 3 boxes are A, B, and C are 3 boxes, right? If I could make cases here, let's suppose one case is like 4, 5, and 10. Right, so 4, 5 is 10 and 10. This is counted in 6 ways. Its ordered is what? It is counted in 6 ways in this ordered solution. Right, it is counted in 6 ways. But if all these 3 boxes are same, we have discussed this concept in different to similar, right? When we are forming cases, right? If all 3 boxes are same, if all these 3 boxes are same, that means A, B, C are same, right? So if A, B, C are same, so assume to be B, B, B. That means in that B, 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 4, 5, 10 will be counted as only one case. If it is same, it will be counted as only one case, right? If these 3 boxes are same, it will be counted as only one case, but we have counted in 6 ways, right? Because we have taken ordered solution, because we have assumed this to be different boxes. So for different boxes, distribution of similar things to different boxes, I've applied S to D concept here. S to D concept, right? That is A plus B plus C is equal to 19. Okay. So A plus B plus C equal to 19, then equal to 21C2 ordered solution. Ordered solution means if I assume these all to be 3 different boxes, now each case is counted in 6 ways, right? Suppose AAB kind of case. Suppose 559 case. 559 AAB is counted in 3 ways here. But actually, if these 3 boxes are same, then 559 is also counted as only one case, right? Because boxes are similar, so you don't know in which box it is 5, in which box it is 5, in which box it is 9. All boxes are identical and close, right? We can't differentiate which ball is in which box. Same for 4, 5, 10. One box has 4, one box has 5, one box has 10 ball. All the boxes are suppose identical, red color identical boxes, right? How will you differentiate which box has got which number of how many number of balls? We can't differentiate, right? That's why in unordered each is counted as one case, right? That basically what we have to convert. We have to convert 21C2 ordered to unordered. We have to convert it to unordered, right? And we perfectly know how to do it, right? In the last 2 videos, we have done so many questions on this, right? How to convert ordered to unordered, right? This is the way to solve this kind of questions. Identical distribution of identical things to identical things, that is similar to similar category, right? So very important concept, similar to similar category. Okay, so if you got this concept right, now we can solve this question now. Okay, so let me write few things, let me rub it off, and you can write a note as in distribution of similar to similar things, in distribution of similar to similar things, we can find unordered solution. In distribution of similar to similar things, we can find unordered solutions. This we can discuss. So our first thing is what? Note point. Note point is what? What is our note point? In distribution of similar to similar, in distribution of similar to similar, we can use the concept of ordered to unordered, and we know how to convert from ordered to unordered, right? In every question of similar to similar, Distribution of similar to similar. In P and C, similar means identical. So if anywhere similar is written, in anywhere identical is written, no difference. Anywhere similar is written and anywhere identical is written, no difference, right? Both are same. So we can use the concept from ordered to unordered. For that, what we have to do? For that, we have to assume boxes to be different. Assume boxes to be different. Okay, these two things we need to do, right? So now we can solve it. A plus B plus C is equal to 19. Since all can be 0, how many solutions? 19 plus 2, 21C2. 19 plus 2, 21C2, right? This is ordered. So how to change from ordered to unordered? So ordered to unordered. So 21C2, subtract the cases of AAB, subtract the cases of AAA, okay? Divide by 6 plus add back the cases of AAB, one case for each AAB, and plus add back the cases of AA. We have done this so many times, right? So here also 21C2, what is the answer? So answer will be 21C2 minus how many cases of AAB here? How many cases of AAB here? See, A plus B plus C is equal to 19. So when A is equal to B, in that case 2A plus C is equal to 19. So A can take how many values? A can take all the values from 0 to 10. Right, sorry, 0 to 9. A can take all the values from where? 0 to 9. So A can take 0 to 9, 10 values, right? So A can take 0 to 9, 10 values. Okay. So when A is 0, when A is 0, B is 0, then C is 19. How many cases for it? 3 cases. When A is 1, that means B also 1 because A is equal to B we have taken. A equal to 1, B equal to 1. What is C? 17. How many cases? 3 cases, right? That means for each value of A, there is one ordered for AAB. And one ordered for AAB means how many? 3 solutions, right? That means for each value of A, 3 solutions. There are 0 to 9, 10 values of A. How many solutions? 30 solutions. That is 3 into 10. That is 3 into 10. Minus. Now there is a 0 case of AAA because 19 is not a multiple of 3. So for AAA, 0 case. Minus 0. Divide by 6. That is 3 factorial. That is 6. Right? Plus add back these 10 cases. So add back these 10 cases and this is 0. So nothing to add, right? So what is the answer? Answer is 21C2 minus 30 by 6 plus 10. Okay. So answer is 21C2 minus 30 by 6 plus 10. We can solve it to get the answer. A super concept it is applied in this kind of question to solve it very nicely. Okay. Now we'll do next question. Similar question, right? Similar question was we just did the last question, na? That question was CAT question, right? So in CAT they expect you to know this kind of concept, right? Okay. CAT 2015, I think, right? Okay, question. Now question. This is the question and this is a very good question. Right? You can solve it. Pause this video for 5 minutes. You can solve it. If you can solve it, feel proud of yourself, right? Concept is same, but combining the concept together to solve this question, right? All the trying to learn all the concept and replicating those concepts in the real time is the real win-win situation, right? So just try to solve it, right? We'll solve it now. The number of ways of distributing 37 identical books to 3 identical bags. So I'll assume these 3 identical bags are different for timing. So I can write the equation as A plus B plus C. There are 3 bags is equal to 37. Each bag contains 3, at least 3, right? So each bag contains at least 3. But now there's no point of giving this 3, 3, 3. Directly we can do, right? Directly we can do that. What is total number of solutions? So total number of solutions for this equation is how much? Giving 3, 3, 3, how much? 37 minus 9, 28 plus 2, 30C2. So total number of solutions is 30C2. So what is our answer? 30C2. Now we have to find unordered case. We have to find unordered because A, B, C are not different. They are same. So ordered, we have to convert from ordered to unordered. Ordered to unordered. Right. So 30C2 minus how many cases of AAB? How many cases of AAA? AAA will be 0 because 37 is 37 is not a multiple of 3. 30C2 minus AAB minus AAA divided by 6, that is 3 factorial, plus adding back the cases of AAB and AAA. This is the concept, right? Now, how many cases for AAB here? Can you solve it? How many cases for AAB? See, A plus B plus C is equal to 37, right? For AAB, both are equal. So 2A plus C is 37, but A has to be at least 3. So when A is at least 3, so C can take, A has to be at least 3. So A can take all the values from 3 to where? 3 to where? Now C can't be 0, right? C can't be 0, so A can take all the values from 3 to, so A can take all the values from 3 to 17 because C has to be also 3. So C is at least 3. So 37 minus 3 is 34. 34 by 2 is 17. So A can take all the values from 3 to 17. A can take all the values from 3 to 17. That's it. A can take this 15 values. That's it, right? So again, A plus B plus C equal to 37. Now A equal to B, we are finding the case for AAB. That means A equal to B. So if A equal to B, 2A plus C is 37. Now all are 3, 3, 3. All are at least 3, right? So when C is at least 3, when C is 3, so 2A is equal to, when C is 3, 2A equal to 34. Therefore, A equal to 17. That means the maximum value A can take is 17. Because what is, if A is 17, what will be that case? That case will be 17, 17 and 3, 37, right? C has to be minimum 3. Okay. So ABC 17, 17, 3, right? So 3 to 17. Okay. How many values I can take? 15 values. 15 values, right? So for each value, again, for each value of A, 3 solutions of AAB. So for 15 values, how many solutions? For 15 values, 15 into 3. So 30C2 minus 3 into 15. Now no AAA because it is not a multiple of 337. So minus 0 divided by 6. Plus how many cases of AAB will add? 15 cases plus 15 cases plus 0. Okay, so this is the answer. 30C2 minus 45 by 6 plus 15. This is the answer for this question. I hope it is clear. So these are very good questions we are discussing. Kindly focus hard, and all the previous videos must be completely covered to understand this very tough concepts, right? Okay. Okay, so next question is, in how many ways 24 identical marbles, okay, in how many ways 24 identical marbles can be distributed in 3 groups, right? So people for this kind of question make cases, right? We won't make cases. We are smarter. We'll do a smart approach. What is smart approach? Same thing. Let the groups be A, B and C. So A plus B plus C equal to 24, right? But 3 groups. There are 3 groups, right? So groups means that these are not 3 people. 3 groups. So in 3 groups means you can't differentiate here, right? That means groups is what? If there are 2 groups, in how many ways 10 people can be divided into 2 groups? So 5 and 5, 4 and 6, right? Because there are 2 groups, so you can't do okay 4 and 6 and 6 and 4. No, right? Because you're counting groups, right? You're not counting to different people, right? In how many ways 10 people can be divided into 2 groups? So you will count 4 people as one group and 6 people as one group, right? So one group, there are 4 people in one group and there are 6 people in one group, right? So you can't say okay 4 and 6 is now one way and 6 is 4 is another way. Think yourself, right? We are dividing people into groups. That means you can't differentiate between the groups, right? Like 4 and 6 and 6 and 4 are only one group, right? So you can't, suppose you're dividing 10 people or 12 people in 3 groups. One group 3, one group 4, in one group 5. So you see, okay, I formed a group of the 12 people with 3 people in one group, 4 people in second group, 5 in third group, right? Simply group you're dividing. That doesn't mean that you can, okay, again say, okay, 3 4 5 is again I can divide 5 4 3. No, right? So groups means what? Groups means we can't divide in, you can't differentiate, right? You can't differentiate. That basically means what? Two groups of 4 and 6 are equal to 6 and 4, right? That basically means what? A comma B is equal to B comma A. That basically means what? A comma B is counted as one solution. That is in unordered. That is in unordered, right? That means again same thing. If I write total solution as 26C2, that if I write total solution as 26C2, right, then you have to convert from unordered to ordered. But mention this point here, I can't write 26C2. I can't write 26C2, right? Another uh, logical derivation from the word group we can have is, if I'm trying to distribute 10 people in two groups of 4 and 6, so I can't say there are three groups of 4 people, 6 people and 0 people, right? A group cannot have 0 people. A group will have at least 1 people, right? So a group will have at least 1 people, so I can't write 26C2 here, right? You should write and you should put a cross also. Writing so that you know that writing it is wrong. You don't do this kind of mistake in examination. Okay, so 26C2 it is wrong. Why wrong? Because group will have at minimum 1 people. So how many solutions? 24 minus 3, 21 plus 2, 23C2. So 23C2 is the total number of solutions, right? Now you have to find again, sorry, I've written different here. Again, you have to find ordered to unordered. I should write here. Sorry. In flow I've written, okay, to find it is ordered. So to find ordered to unordered. Ordered to unordered. Right, ordered to unordered we have to find. So this 23C2 is what? 23C2 is ordered. To convert to unordered, again same thing. So again same thing, right? We're doing same thing. 23C2 minus AAB cases. Right, I should write here only. Okay, so by this time you should know all this concept now, right? So 23C2 minus AAB cases minus AAA cases divided by 3 factorial, that is 6, plus add back the one case for AAB each and one case for AAA. This is the common funda, right? Now 23C2 minus AAB cases. How many cases for AAB? So same thing, A plus B plus C equal to 24, right? So see, 24 is a multiple of 3. So there will be one case for AAA, right? That is 888. So one case for AAA, right? When it will occur? It will occur at A equal to 8. At A equal to 8 it will occur. Okay. Now when A is equal to B, when AAB cases for A equal to B, that means 2A plus C is equal to 24. So A can take all the values from 1 to where? From 1 to, now C can be, C cannot be 0, right? C can be how much? C has to be at least 1. That means 2A is equal to 23. That means A is 11.5. That means A can be 11 at maximum. A can be 11 at maximum. A can't be 12. If A is 12, C is 0. C is 0 means that one group has 0 people. Not possible. There, in a group, there has to be at least 1 people. So A equal to 1 to 11, but out of 11, 8 is already counted here. 8, A equal to 8 is already counted in A part, right? So 1 to 11 minus 1, that is 10. 10 values, right? So it should be 23C2 minus 10 into 3. Each AAB will have 3 solutions. Minus 10 into 3. Minus 1 divided by 6 plus 10 solution. Add back 10 solution plus 1 solution. This is the answer for this question. Okay. So by this time, I hope you are absolutely clear with how to when to apply this concept, right? All the questions of similar to similar as well as distribution of identical things into groups. You can apply same concept of converting ordered to unordered, because groups also, if you say there are two groups of 4 and 6 people, one group of 4, one group of 6, you can't say you can reverse it, right? Now there are another group of 6 and 4 people, right? Group is always counted as 1. 4 people and 6 people group is always counted as 1, not 2. 4, 6 and 6, 4. Okay. And then similar to similar also same thing, right? So you assume those boxes or bags to be different, okay, and by that different you take the ordered solution, and since they are different, each case will have ordered solution, then you convert from ordered to unordered, right? So in this kind of questions we apply ordered to unordered concept. Okay. Okay, thank you. In next we'll discuss how to apply the similar kind of concept in different to similar. Different to similar. Okay, thank you. And different also. Different to different and different to similar, right? Thank you.